Various concepts of insulation were covered in my earlier video. Let us explore some more aspects of the insulation. Electric field strength is expressed in kV per mm. It decides the required thickness for a given voltage. Let's apply voltage V across the insulation. Due to the applied voltage, positive charge is created on one side and a negative charge on the other side. Electric field E is produced due to these charges. Electric field means that a force QE is experienced by a positive charge Q in the direction of the field. Similarly, a negative charge minus Q experiences a force QE opposite to the direction of the electric field. Electric field strength E is equal to V by D, where V is the applied voltage and D is the thickness of the insulation. Electric field strength E increases with the increase in the voltage and vice versa. Electric field strength decreases with increase in the thickness of the insulation and vice versa. Let us understand breakdown strength of the insulation. In case of insulators, electrons are tightly bound to the atoms. Electrons are not dislodged by a nominal voltage. However, if a large voltage comes across the insulation due to any reason whatsoever, electrons are dislodged and breakdown in the insulation takes place. When electric field strength exceeds the breakdown strength of the insulation, insulation fails. Invariably, the term dielectric is used in place of the insulation. There is a slight difference between these two terms. Dielectric has dipolar molecules. Dipolar molecules mean that positive and negative charges in the molecules are separated by a distance. Normally, these molecules are randomly oriented. These are aligned in the direction of an electric field E when electric field is applied. It is not necessary that insulating material is dielectric. In large electrical machines, the main constituent of insulation is mica, and mica is dielectric. Hence, these terms are used interchangeably. E.g., we say the electric strength of insulation in place of a breakdown strength of a insulation. We see electric discharges in everyday life, e.g. in electrode welding. Electric discharge means flow of current in the air. Whenever there is a loose connection and electrical strength exceeds 3 kV per mm, electrical discharge takes place. Electric discharge is also observed in many places of insulation. When it occurs on the surface of the coil, it is called surface discharge. Electric discharge in the overhang portion of a coil may be visible. Visible discharge is called corona. It may also occur inside the insulation. It is called partial discharge. Now let us understand how electric discharge is produced. When an electric field is applied, free electrons in the air accelerate and hit the air molecules. Electrons are dislodged from the air molecules when electric field strength exceeds 3 kV per mm. Newly liberated electrons hit more air molecules. More electrons are liberated. There is avalanche of electrons. These electrons move towards positive electrode. Thus the current flows. Let us see how light is emitted by electric discharge. When free electrons hit atom, it imparts energy to it. The atom is excited and electrons move to a higher orbit. Sooner or later, electrons come to a normal state, releasing energy, and thus light is emitted. Let us see why electric discharge produces heat. During discharge, electrons and positive ions move toward opposite direction. That is, air becomes conducting, but the resistance of air is very high. This results in large heat due to large I2R loss. Let us see how electric discharge produces sound. There is sudden increase in pressure due to heat. There is compression and rarefaction of air. Thus, the sound is produced. Now let us understand various currents produced when a DC voltage is applied across the insulation. When a DC voltage is applied, charges accumulate on both sides of the insulator. This results in a capacitive current. This current is very high and is of a very short duration. When a voltage is applied, the electrics in the insulation align in the direction of electric field. Energy or current is required to align these molecules. This current is called absorption current. This current reduces from a high value to zero. There are always imperfections in the insulation. That is, there are leakage paths on the surface and inside the insulation. Hence, leakage current flows through these paths. This current is constant. Understanding various currents when a DC voltage is applied across the insulation helps in understanding various topics of insulation like absorption coefficient, polarization index, etc. These topics will be covered in future videos.